Hello everyone. We are the Tech Divas final year BTech CSC student from Karmavir Bhaura Patil College of Engineering Satara. Our team members include Pranali Mane, Poonam Mane, Harshali Patil and Rachna Satamate. Under the valuable guidance of Professor Aniruddha Shirsagar sir, we have successfully implemented our final year project titled Disaster Damage Assessment and Response Framework. Usually, when the disaster happens, it takes a long time for affected people to get help. Damage reports are done manually and compensation is delayed. We wanted to create a system that does this automatically using technologies. Our main goal is to use machine learning to check the level of damage from photos and then use blockchain smart contracts to send the correct compensation amount automatically and transparently. This project is designed to automate the damage assessment process after a natural disaster and provide quick, transparent compensation using machine learning and blockchain smart contracts. Before we begin the demo of our project, let me first show you the disaster damage image dataset that we have used. The dataset includes image categorized into two main folders, pre-disaster and post-disaster. Let me start by opening the pre-disaster image. As you can see, we have followed a specific naming conventions to easily identify and map images. This particular image shows a house before a fire incident. Now let's look at the corresponding post-disaster image of the same house taken after the fire. In this image, you can clearly observe a structural damage caused by the disaster. This type of image pairs are used by our ML model to access the extent of damage, which is a critical part of our compensation framework. Now let's start with the user flow. First, the user needs to register and log in through the claimant portal by entering email and password. After login, the user must agree to the terms and conditions before proceeding further. Once logged in, the user fills in all the property details such as name, location, type, description, etc. Next, the user uploads the pre-disaster image of the property. Here, I click on Upload. Once uploaded, it is displayed in the user dashboard along with all entered details. After that, user uploads the post-disaster image. Now, both the before and after images are displayed on the dashboard. These two images are now sent to our machine learning model built using convolutional neural network. We trained our model using over 500 labeled images effectively. The model compares both the images and generates a percentage, that is damage percentage. For example, in this case, the model detected 81.25% of damage. We also support batch processing of multiple images using image folder from Google Drive. Here you can see it is calculating changes for multiple image pairs. This is a change heat map overlay. which clearly shows the area of damage between two images. Here you can see our model achieves an accuracy of 90.20%. Now let's switch to the admin panel, which is used by the government authority. After login, this is admin panel. The admin can see all the users' requests and damage reports. Now I click on submit damage for the user to initiate the compensation process. This opens the blockchain compensation portal. Here I click on connect wallet to connect the user's wallet using MetaMask. The system fetches the user's wallet address. We have used Hardhat for smart contract deployment on the Sepolia Ethereum testnet. Now I enter the damage percent, that is 81%. Then I click on submit damage. A MetaMask pop-up appears and I click on confirm transfer. Now the portal waits for transaction confirmation. The smart contract automatically calculates the compensation based on damage severity, insurance policy, and property value. In this case, the compensation is 4,15,862 rupees, which is equal to 2 ETH. This amount is deducted from the government wallet, which had 100 ETH earlier. After this transfer, the balance is updated to 98 ETH. This is the user MetaMask wallet. Earlier, the user had 9,900 ETH and now it is updated to 9,902 ETH after receiving the 2 ETH compensation. Let me show you another example. Now I enter damage percent as 32%. Based on our smart contract logic, the system calculates a lower compensation as the damage is minor. This proves our smart contract can dynamically adjust payouts based on input conditions, ensuring fair and transparent distribution. In conclusion, our project helps to automate disaster damage assessment and provides fast, secure compensation using AI and blockchain. It reduces manual effort, speeds up recovery for affected people, and brings transparency into the system. Thank you for watching.